Uh, Welcome back, Stella. I hope you are doing well. So today we are going to see basically how to integrate these two types. Firstly, you have to I rectified some things here. I instead added here nx and here nx, also here nx. I added with n belonging to r star, where a, b, and c are real numbers. You understand? But but a, b, and c, not all of them must be equals to zero, because if a, b, and c are equals to zero, this function will be 1 all over 0, which is undefined. You understand? So a, b, c, two of them can be zero, but in fact, a, let me give conditions. A must, yes, a can be zero. A belongs to R, but C, let me precise, B and C, let me give a condition. B and C, when one is zero, the other must not be equals to zero. That's the condition. So this B and C, let's say they belong to R star. But if B is zero, the other must not be equals to zero. Because if this and this are zero, we are instead left with integrating what? 1 over A. If A is a real number, it's like we are integrating a constant. You understand? Okay. Now, without wasting time, let's move to this first one of type 4. Okay, we are to integrate this. How do we integrate this? To integrate this, just follow these steps I'm going to give you. The first one, step 1, you first of all, let me give you types of integrals that resemble this. They can ask you to integrate, for example, 1 all over 3 sine square x. You integrate it using this approach. They can ask you to integrate 1 all over 3 cos square 7x. You are going to integrate this using this approach. They can ask you to integrate 1 all over 7, let's say, plus 8 sine square 5x plus 9 cos square 5x. This angle must always be equal to this angle, or let's say minus here. They can ask you to integrate something like this, so it's still the same thing. They can say ask you to integrate 10 minus 5 sine square, let's say 8x. It's still the same thing as this. So whenever you are asked to integrate such things, the first step, you let t to be equals to, you can say u, you can say w, depends on you. You let your t to be equals to tan of the angle that's inside here, tan of nx. Make sure this angle is the same as this angle. You let t to be equals to tan nx. After doing that, you will draw your triangle. You draw a right angle triangle. You draw your right angle triangle. You know that tan theta is equals to what? Opposite all over what? All over adjacent. So if tan nx is equals to t, this t is the same as t on 1, meaning this is the opposite, t is the opposite and 1 is the adjacent. So if this is my right angle triangle, the angle is 1 is what? Nx, the angle. I can decide to put my angle here or up here. It depends on you. What is the side opposite? If my angle nx is here, what is the side opposite to nx? It is this side. So I'll take my t and put it here. And what is the side adjacent to nx? This side. So I take my 1 and put it here. Naturally, the hypotenuse will be what? The square root. If you apply Pythagoras theorem, the square root of 1 plus t squared. Let's call this triangle A, B, C. Okay. Okay. Now, after letting your t to be this and drawing this triangle, the next thing you have to do is what? You need to find what? Sine what? nx and cos nx. You understand? Because this is a substitution you did. You have to substitute sin nx here, cos nx here, and you also have, let me write this. You also have to find what? Dx. Is that okay? Very good. So, and remember, sine, if I write sine to the n of alpha x, is the same thing as sine alpha x, all that to the n. Don't forget it. Okay, now let's find sine nx. So step two, finding sine nx. We have to find sine nx, cos nx, and what? Dx in terms of t, because we related our t to be tan nx in terms of t. Okay, very good. That's the step 2. Let's start by finding sine nx. We can find sine nx from our triangle. From triangle ABC, comma, we have sine nx, which will be what? Sine is equals to what? Sine is equals to what? We know that sine is what? Opposite all over hypotenuse. Sine is opposite over hypotenuse. From the triangle, opposite is t all over what? The hypotenuse, square root of 1 plus t squared. That's our side x. Cos nx will be equals to what? Adjacent all over what? The hypotenuse. That will be 1 on the square root of what? 1 plus t squared. Is that okay? Now we have to find our dx. We have to find dx. To find dx, we shall use what? We shall use our substitution. We just differentiate it implicitly. Is that okay? From t equals to tan nx. If I differentiate this implicitly, I'll have, when I differentiate this, I have 1 times what? Since I was differentiating with respect to t, I write what? dt. When I'm to differentiate this, so this will be equals to, how do you differentiate tan nx? I'll first give you the rapid way of doing it. This is simply the derivative of this. If I'm to differentiate this, is simply equals to nx prime, and I differentiate this. I will differentiate this one without affecting the nx. So this will give, when I differentiate tan of something, I have what? Sec square, or 1 plus tan square what? Nx. And when I differentiate this, I have n into what? 1 plus tan square nx. You can still do it using the chain rule, but I don't like wasting my time using the chain rule because that's too much of writing. If my y, let's do it using the chain rule. Tan, this is still the chain rule, but in a fast way. You have to differentiate tan nx. I'll let my u to be equals to what? Nx. This implies my y will be equals to what? My y will be equals to tan u. So the formula says dy dx is equals to what? Dy du times du what? Dx. Is that okay? When I differentiate y with respect to u, this gives me what? 1 plus tan square u, or sec square u, times what? When I differentiate u with respect to x, this simply gives me n, which is the same thing as n into what? 1 plus tan square. What was u? Nx. All that, and I close it. You see that it gives the same thing. So I don't like wasting time to show all these steps, whereas I can just do this. You understand? So to differentiate, I have to differentiate this, a composite of function. I differentiate what is inside times I differentiate this without affecting what is inside. You understand? Okay. Let's go directly. Let's continue. So the derivative of this will give what? Nx prime into what? the derivative of this without affecting nx. 1 plus tan square what nx. Is that okay? Since I was differentiating with respect to x, I'll multiply all of this. These are big brackets. All of this by what? Dx. So it implies dt will be equals to what? When I differentiate this, I have n into what? 1 plus tan square nx times what? Dx. This implies, let's make dx the subject, dx will be equals to dt on n into what? 1 plus tan square nx times n. Is that okay? But recall that, but t was equals to what? Tan nx. This implies our dx will be equals to what? Dt all over what? N into 1 plus, when I replace tan nx by t, I'll have here t square. So this is our dx. So after doing this step, after finding sine nx and cos nx, what we are supposed to do is what? Let's go to step 3. The step 3, you substitute sine. So you substitute sine nx, cos nx, and dx in the integral, that was given. When I'm talking of the integral that was given, that is the integral of what? Dx on a plus what? B sine square nx plus c cos square nx. So you replace, don't forget sine n alpha x is equals to sine alpha x all that to the n. So you substitute it here. You will take the value of sine nx, you come and substitute here. Take the value of cos nx, you substitute it here, and you take the value of dx, you substitute it here. You will have an expression that you will simplify, and the resulting expression, you are going to integrate it. So substitute sine nx cos nx dx in the integral that was given, that is in this, and integrate it. When you will integrate it, your answer naturally, because when you substitute it, your answer, everything that will be inside will be in terms of t. When you will integrate it, your answer will be in terms of what? T. When you have your answer in terms of t, don't forget that your tan what? Your tan nx was equals to what? T. So if I'm to make x the subject, it simply means nx will be equals to what? The tan inverse of what? T. And x will be what? 1 on n tan inverse of what? T. So you will take your where you have t, you will substitute it. No, hey, this is an error. This is a small error I did. So when you will do your integral, when you finish integrating, because the result you will have here will be in terms of t. After integrating, you have your answer in terms of what? T. But remember that the integral that was given to you, the variable was what? In terms of x. So when you will see t in your answer after integrating, you will substitute that t by what? Tan nx. You get what I'm saying? So this is how you are supposed to proceed whenever you are dealing with integrals of this form. Let's move to the next one. We shall see examples in the next video. So let's move to the b. The b, we are supposed to integrate dx on what? A plus b sine nx plus c cos nx. Very good. How are you supposed to integrate this? It's very simple. Let me first of all give you forms. They can ask you to integrate 1 on sine x it is of this form. This is cosec x. They can ask you to integrate 1 on cos x, which is sec x, which is of this form. They can ask you to integrate 1 on, let's say, 7 sine 8x. It is still of this form. They can ask you to integrate 1 on, let's say, 7 sine 5x minus 6 cos 5x. It is still in this form. You understand? It's still in this form. They can still ask you to integrate what? But they can still ask you to integrate 1 on, let's say, 9 cos 7x. It is still of this form. Is that okay? Okay. Now, before continuing with this, let me ask you first of all a question. What if you are asked to integrate um, what if you are asked to integrate a plus b sine nx plus, for example, plus c cos square nx? How are you going to integrate it? Because it's no more it's no more cos nx here, it's instead cos square nx. Think a bit. How are you going to integrate this? The best way to go about integrating this is putting this in a linear form. If you can recall, when I'm talking of linear form, if you can recall, you know that cos n theta, cos sine n theta is equals to 2 sine n theta on 2 cos n theta on 2, and cos n theta is equals to what? These are the three forms. You understand? And you see that if I come back here, you see that cos cos uh, cos alpha, if I will say alpha x is equals to what? 2 cos square alpha x on 2 minus 1. So you see that you can make this the subject and write it in terms of what? This one. You get what I'm saying? So that's how, in fact, we shall see that in exercises. Don't bother yourself. So let me show you how you are to integrate this last form. Now you want to integrate this. The first step is you let t to be equals to tan of, make sure the angle that's here is the same angle that's here. You let your t to be equals to tan of nx on 2. It is not more t being equals to what? Tan nx. So be very careful. In the last form, in the previous form, when it was sine square nx plus cos square nx, your substitution is t equals to what? Tan nx, the angle that's here. But when you instead have sine nx, not sine square, plus c cos nx, the substitution that you have to do is t being equals to tan nx, this angle, divided by 2. After doing that, you naturally draw your right angle triangle. Let me call this angle. The angle that I'm to put here is the angle of tan, that is nx on 2. This tan nx on 2, this t is the same thing as t on what? On 1, which is opposite all over what? Adjacent. Very good. Now, what is the opposite side to this angle? It is this side. So this will be t. And what's the adjacent side to this angle? It is this side. So this adjacent, this one, I'll put it here. Naturally, the hypotenuse becomes 1 plus what? T squared. Is that okay? Now, after doing this, the step 2, what you're supposed to do is what? You finding what? Sine. We are to substitute sine nx and cos nx. What you have to find is, you have to find sine nx, cos nx, and what? Our dx that's up here. Finding sine nx, cos nx, and what? Dx in terms of t, because our variable that we left was what? T. If you instead set let u to be equals to tan nx of 2, you will find it in terms of u. Very good. Now let's call this triangle. I usually like to name the apexes of my triangle for me to be, whenever I want to call it, it will be very simple. Now, from triangle ABC, from triangle ABC, I have to find what my sine with. I have to find what the aim is to find what the first one we have to find our sine nx. The problem is that in the triangle we instead have which angle? Sine nx on 2. Recall this formula. We know that sine alpha x is equals to what? 2 cos what? Is equals to 2 sine alpha x on 2 times what? Cos alpha x on 2. These are the formulas I asked you to remember last time. Remember these four formulas. Remember them. They will be very helpful for you, whether it's in trigonometry or in some exercises. So, using this formula, our sine nx will be equals to what? 2 sine nx on 2 cos what? Nx on 2. Is that okay? So let me wipe this. So we need to find sine nx on 2 and cos nx on 2 from what? Our triangle. Is that okay? So this will be equals to 2 times what? Sine nx on 2. Sine is what? Opposite all over hypotenuse. The opposite to this angle is what? T. So this becomes t all over hypotenuse square root of 1 plus t squared times what? Cos nx on 2. From our triangle, cos nx on 2 is equals to what? Adjacent all over hypotenuse. So times 1 on the square root of 1 plus t squared. So this implies our sine nx will be equals to what? Root a times root a is a. So this becomes 2t on what? 1 plus t squared. That's our sine nx on 2 in terms of t. Let's find cos nx on 2. Cos nx. Let's find cos nx. Cos nx, if we come back to this formula, we can either use this formula. Cos n theta is equals to what? Cos square n theta on 2 minus sin square n theta on 2, or you use this or this formula. Is that okay? Let me use the second formula. You are free to use any. Cos nx on 2 will be equals to what? 2 cos square nx on 2 minus 1. So this will be equals to, remember, cos nx is equals to what? Cos x all that to the n. So don't forget that. Don't forget that. So this will be equals to my cos nx on 2. Wait. This will be equals to 2 into what? Cos nx on 2 from the triangle, from our triangle is equals to what? It's adjacent all over hypotenuse. So 1 on the square root of 1 plus t squared. 1 plus t squared. All that square, because there is a square here, minus 1. This will be equals to this 1 square. This 1 square is 1. So I'll have 2 on this thing square. I'll have 1 plus t square minus 1. So this implies our cos nx will be equals to what? This will be 2 minus what? 1 plus t square all over what? 1 plus t square. So this implies our cos nx will be equals to what? This times 2 minus 1 is 1. This minus times t square, this will become t square on 1 plus t square. So that's, we have already our cos nx in terms of t. Now we have to find our dx. We have to find our dx, we simply need to differentiate what this implicitly. Okay, so recall that t is equals to what? We let our beginning, our substitution was t was equals to tan of what? Nx on 2. So let's differentiate it implicitly. When I differentiate this, I have 1 times dt being equals to, when I differentiate this will give me nx on 2 prime, and when I differentiate the whole of this without taking into account the nx, the derivative of tan of something is what? Sec square that thing is equals to the derivative of tan u is equals to what? Sec square u, or 1 plus tan square u. So I'll have 1 plus, let me put big brackets, 1 plus tan square nx on 2. Since I was differentiating here with respect to x, I'll write here dx. So this implies my dt will be equals to, when I differentiate this, I have what? N on 2 into 1 plus tan square nx on 2 times what? Dx. I then make x the subject, dx the subject. This implies dx will be equals to what? Will be equals to 2dt on what? N into 1 plus tan square nx on 2. Is that okay? But our t was equals to what? Tan nx on 2. So I will replace tan nx on 2 here by what? T. So this implies our dt will be equals to what? 2 dt all over what? N into 1 plus t squared. Because when I replace tan nx on 2 by t, all that square will make t squared. So this is dx, pardon, this is dx. So this is our dx. So after finding your cos nx and your sin nx, cos nx, and dx, the next step is what? The step 3. You substitute sin nx, cos nx, and dx in the integral that was given to you, that is integral of dx on a plus b sin nx plus c cos nx. So you substitute it inside here and integrate the results. You integrate the result. You understand? So after integrating the results, your answer will be in terms of what? Because when substituting this, naturally the integral you are doing will be in terms of what? T. After integrating the result, your result will be in terms of what? T. But remember that your t was equals to what? Your t was equals to this. So wherever in the final result, when you would have integrated the expression in terms of t, the final result, replace where you see t with what? Tan of nx on 2, because the starting integral was in terms of which variable? X. So that's basically how you integrate these two forms of type 4. So here I said in this type, the substitution has to be what? T equals to what? Tan of, make sure the angles here are the same, tan of this angle. Whereas when you are in this form, the substitution has to be what? You let your t, make sure first of all these angles are the same. You let your t to be what? Tan of the angle that's inside here divided by 2. Is that okay? So that's how basically you go about to integrate these two types. In the next coming videos, we shall see examples in order to practice well this type of integrals. So see you in the next video. Try to go back all what was being done and master it. So in the next video, we shall see we shall dive into exercises. So see you in the next video. Take care.